Everyone, my name is Anderson Kanju, a statistician, and today I'll walk you through my recent project on modeling student performance. Let's dive into the details. First, I started by setting myself a set of objectives. Number one, I wanted to model the performance of model the performance index using the given variables. Number two, I wanted to understand the impact of each variables on performance index. Number three, I wanted to find the average performance index by extracurricular activities. And finally, I wanted to find the average performance index based on sleep hours. So let's dive into the Jupyter notebook. I first started by importing the necessary libraries or loading the necessary libraries. So pandas, numpy, matplotlib, sklearn, and plotly. And then as well as loading the dataset, I started by viewing the head of the dataset to ensure that indeed this is the dataset that I saw or I am supposed to use. First, I got this dataset from Kaggle. So I first started by viewing the head or the dataset head, and indeed it was the actual dataset that I'm supposed to use. Next, I checked for missing values and found none. I then converted categorical variables into numeric for analysis, because you cannot do analysis with categorical variables or with an object data type. It will give you an NA or an error for that case. Okay, so the next step, I did some summary statistics to view like how is each variable distributed, or just simply to understand how by the each variable. So for our studies, you can see that the mean is 4.99. We have 10,000 entries. The standard deviation is 2.5. The minimum is 1, the maximum is 9. The first percentile is 3. Second percentile is, sorry, not percentile but quartile. Then the third quartile is 7. So just to have a view of each of your variables, you can apply like for the mean. The mean our study is 4.99. The mean previous course is 69.4. The mean for extracurricular activities, of which is a categorical variable, so that means you should not use it anywhere. So then the sleep hours is the average sleep hour is 6.53. The average question papers practice is 4.58, and the average performance index is 55.24. So next, to ensure normality, I had to plot a histogram for each data type, not the data type but for each variable. So you can see our studies is kind of uniform, which is good. Previous course is uniform. Extracurricular activities is a categorical variable. Sleep hours, we have some gaps over there, but still it's kind of uniform. Sample questions papers practice is uniform as well, and voila, the performance index is normal, which is a very, very good indication that we can proceed with modeling our data. So one of my objectives was to find the average performance based on sleep hours. So to do this, I presented this. We have to find the mean. We have to group the performance index by sleep hours, and then find the mean for each sleep hours, because the sleep hours are only 4, 6, 5, 7, 8, and 9. So we can group them very well. So as you can see from our pie chart, for students who slept for 4 hours, had an average performance of 53.79. Those who slept for 6 hours had an average of 54.66, and so on and so on and so on and so on. And you can see now that the average performance of those who slept more is actually the average performance of those who slept more is actually the highest than those who slept less. That is from the pie chart. Next, I wanted to understand the performance index, the average performance index based on extracurricular activities as well. Here also you group the performance by extracurricular activities, find the mean for each category, and presented using this using a bar graph. And you can see those who engage in extracurricular activities, my 0 is the engaged and my 1 is they did not engage. So extracurricular activity, those who engaged had an average performance index of 555.7. Those who did not engage had an average performance index of 54.75. So this indicates that those who engage in extracurricular activities had a higher performance index than those who did not engage, according to our bar plot. Okay, next, don't worry about the df columns. I just wanted to say I just wanted to get my variables so that I can use them and not mistake the name of the variable, because if you mistake them, then your code will bring an error. So next, I did a heat map, or what statisticians know as a confusion matrix. So that this is to understand the relationship between variables, your variables in your data set. So I can see if I come and hover over here, I can see that performance index and our studies here have a relationship of 0.3. Bearing in mind correlations lie between -1 and 1, where between -1 and 0 is a negative relationship, or for example, and between 0 and 1 is a positive relationship. So for our case, it's a positive, but it's very low or a weak positive. Then performance in previous calls is a strong positive, 0.9. Then performance in the and extracurricular activities is a strong negative, not weak negative. Then you go by and you can still apply the same. So don't worry about this one. It means performance index against performance, a variable in itself. Yeah, it will definitely, these diagonal matrix, all of them are 1. No, so next I define my x, no, not my x, my independent variables, or the variables that affect. And then I defined my dependent variable, the variable that is being affected. Then split my data into training and test sets. My test set for this project was 30%, test size that is. I then fitted the model using the train, because you cannot use the test data to fit your model. Now I want to evaluate the performance of the model, so I have to predict. So don't worry about this, is the name of the variable, so it's a prediction based on the 30% of x. So now the MSE is a tool that you can use to evaluate the performance of your model. Or okay, we normally use RMSE, which is the square root of the mean square MSE, then the R squared. And then now, so my third objective was to model, my first objective was to model, which I have indeed done. Then now from the mean squared, which is 4, which is implied that the RMSE is 2.1, which implies that the value, the difference between the actual value and the predicted is 2, which is a very good indication. The R2 scores, which is 0.98, indicates that 98.901 of the variance in the performance index is indeed accounted for by the independent variables, which is very, very, very good. And then on understanding how each variable affects the performance index, you can see the hours of studies. So the 1 unit in our studies leads to 2.85 units increase in the performance index. 1 unit in previous course and contributes to 1.015520 increase in the performance index. 1 unit increase in extracurricular activity, but it's a categorical variable. Sleep hours 1 unit increase in sleep hours lead to an increase by 0.47967 of the performance index, and so forth. And holding all factors constant, you don't have our studies, you have no previous cause, you did not engage in any you did not engage in extracurricular activities, you did not sleep, you did not practice any question, then the constant or your performance index will be negative 33.254, which is approximately 0 because the performance index ranges from 0 to 1. Thank you for watching, and feel free to reach out if you have any questions.